Hello, Math 2. This is day 2 of Module 8. Today we're going to talk about arcs of a circle and central angles. A little warm-up here, naming all the different parts and different lines, segments, and rays we can see in a circle is what we're going to start with. So, if we had to name a radius in this diagram, a radius in the diagram would be either a segment AC or segment CD. And remember, radius is a segment. Now, a diameter in this, alright, remember diameter is a chord that passes through the center, which would be chord AD. Okay, then there are a couple of different chords in here, but we're going to say HB is a chord. We're also going to say AD is a chord because it's a specific type of chord known as the diameter. A secant in this diagram is line JK. A tangent line is GE. GE. Okay, and the point of tangency, is where the tangent line intersects the circle, which is at point F. Okay, so these are all the parts that we talked about yesterday, so make sure you know these. So today we move on to talking about what we call an arc of a circle. An arc is a connected part of the circumference of a circle measured in degrees. Okay, now we use a symbol for an arc, and the symbol, right, is just a little arc above. And like I said, it's measured in degrees. Now there are three types of arcs we talk about. One is a minor arc, and that is an arc whose measure is less than 180 degrees. So when I look over here, this arc here, right, is a minor arc because that's less than 180 degrees. And if I look at it, I would name that minor arc BC. So when you name a minor arc, you name using 2 points, right? So use only 2 points to name a minor arc. Now a major arc, right, is an arc whose measure is more than 180 degrees. So when I go over here, right, from B to C, that's less than 180 degrees. But if I go this way, right, this arc would measure more than 180 degrees, right? So if we were to name that arc, we would name that arc B, D, C. And if you look, if I was to go from B to C the long way, I would go from B around to D, around to C. So you have to know, when you name a major arc, you name a major arc using 3 points. That's right away how I tell the difference of which direction to go. If it's named using 2 points, I go the short route. If it's named using 3 points, I'm going to use the long route. Now a semicircle is an arc whose measure is 180 degrees. Okay? It's basically half a circle. A circle is 360 degrees. So it's half a circle or 180 degrees. So right away when I look here, this would be a semicircle and this would be a semicircle. Okay? So what do we know about all of these? Well, now we look at it and we talk about this idea of a central angle. A central angle is an angle whose vertex is at the center of a circle. So when I look here, this here is a central angle. Okay? Now, one thing you have to know is the measure of the central angle is equal to the measure of the arc. So that would be this arc here. So the angle that eats the arc, those two are congruent. Okay, and that's very, very important as we move forward. Okay, so let's look at some examples here. Find the measure of arc DF. Remember, the symbol above here tells me it's an arc. So arc DF is this arc here. Well, if I follow the lines that make up the central angle, what's the measure of the central angle? 40 degrees. So arc DF is equal to 40 degrees. Okay? Now, the measure of arc NML. If I look at this, right? If I trace from N to M to L, you have to know, because it's named using 3 points, that it's going to be more than 180 degrees, right? Making it a major arc. So how do I name this, right? Or find the measure of this? Well, if this central angle is 110, this arc is 110. So that minor arc. So this arc here is 110. Well, how many degrees are in a circle? 360. So if this arc is 110, arc NML is equal to 180 minus 360 minus 110, which is 250 degrees. So that entire arc would be 250 degrees. Okay? Those are two straightforward ones, but you got to know, 2 points, it's going to be less than 180 degrees. 3 points, it's going to be more than 180 degrees. So over here, first thing I want to do here is I'm looking for these arc measures. So this is 40 degrees, 80 degrees, 110. How can I find this central angle? Well, what do all 4 of these angles have to add up to? Well, those angles have to add, those angles have to add up to 360, right? So right away, this arc is 40 degrees, this arc is 80 degrees, this arc is 110. So what is the measure of arc GF? Well, if I do 360 minus 110 minus 80 minus 40, I would get 130 degrees. Right? So right away, arc GF is 130 degrees. Now, arc GE, if I highlight it here from G, I'm going to go the short route. I'm not going to go the long route because it's only named using 2 points. So short route is from G to E. So what am I going to do? I'm going to say GE, arc GE is 40 plus 80, which is 120 degrees. Now arc GFE, right? That one, arc GFE, is going to be 130 plus 110, which is 240 degrees. Okay? Now over here, number 4. First thing I'm going to do is fill in these angle measures. This is 58 degrees. To find this angle, I'm going to do 180 minus 58, which gives me 122 degrees, which means this arc is 122 degrees. And then this angle is going to be 180 minus 32, which is going to give me 148 degrees. So now this arc is 148 degrees. So now arc AB, right away, I'm going the short route. So arc AB is going to be 148 degrees. Now arc ABC, A to B to C. Since A and C are the endpoints of a diameter, right away I know that's exactly half a circle, or 180 degrees. Now from B to D, right? From B to D, 58 plus 32 is going to give me 90. So that's 90. B to C, I know the central angle is congruent, so that's 32. Angle COD we already found is 58 degrees. And then CDA, from C to D to A, that is exactly 180 degrees. Go ahead, try the homework, and we'll go over this next time in class.